But that's the last thing I want to talk about real quick. And this one will be really short. This part will be really short here. Shooting stars. What can we tell about them? What can we tell about them? And this is the last thing I'm going to talk about. If shooting stars do look like they're moving really fast, what does that tell us about shooting stars? Because you can see fast motion on a shooting star. Based on everything we've just said, what's true about shooting stars? If you can see the fast motion, they must be really close to us. Yes, they must be really close to us. They are moving really, really fast, but the fact that we can see that fast motion means they must be really close to us. In fact, shooting stars are not out in space. They're close enough that they are in the atmosphere of our planet. Okay? So, are shooting stars stars? Yes or no? Are shooting stars stars? Keep in mind, they're close enough to us to be in the atmosphere. No. They are definitely not stars, right? They're definitely not stars. If there was a star close enough to be in our atmosphere, it would vaporize our entire planet, okay? So shooting stars have nothing to do with stars. And somebody actually pointed out a lot closer to what they are. What they are, shooting stars are just solid chunks of material falling from space. Bits of asteroids, bits of comets, bits of... mostly asteroids and comets that are falling towards a planet. And somebody actually said the technical name for them, and I'll write it down. They are called meteoroids. They're called meteoroids. So a chunk of solid material falling from space is called a meteoroid. And these are just pieces of asteroids and comets, okay, falling towards a planet. This is very similar to another word. This is very similar to another word, which you probably have heard. It's called meteor. That is not the same thing. A meteor is not the same thing as a meteoroid. The meteoroid is the solid chunk of material that's falling. The meteor is the streak of light that it produces. Okay? A meteoroid is a chunk of rock that falls from space. The meteor is the streak of light that it makes as it flies through the atmosphere. Okay? Now, and if we were in class, I would actually bring in some stuff to actually look at here. How does the meteoroid make a streak of light? How does the meteoroid make a streak of light? A lot of people think that it's friction, right? Because if you take a rock and rub it on the air, if I do this, what's going to happen to my hands? If I keep doing this for a while, what's eventually going to happen to my hands? How are they going to feel? Yeah, they're going to get hot, right? They're going to get hot. I can produce heat with friction. And technically, you can produce friction on the air, too. So as a rock or a chunk of material falls from space, it could rub the air and cause friction and make some heat that way. And if you made it hot enough, then things could start to glow. But it turns out that meteoroids move so quickly through the air that they can't generate very much heat in any one place. So they're actually moving too fast for the heat of friction to get enough to make a glow, okay? So instead, what's happening? Check this out. Everybody do this with your hand real quick. Make like a little cup. Make a little cup with your hand, okay? Now, do this. Just do this real quick. Now, when you do that, do you feel the air trying to get out of the way? Do you feel that little bit of wind on your hand when the air gets out of the way of your hand? The same thing happens when a meteoroid falls through the atmosphere. When the meteoroids fall through the atmosphere, the air in front of them tries to get out of the way, right? It tries to get out of the way. But, here we go, but because the meteoroid is moving so quickly, the air in front of it can't get out of the way. And so more and more air gets trapped in front of the meteoroid. And what that does is it causes the air in front of it, kind of like if you were standing on some train tracks and a train came really fast. If it came really fast, you might get stuck on the front of the train, like, as the train pushed you back. That's like the air stuck on the front of the meteoroid, like, oh no! Now, when that happens, the air gets compressed. The air gets compressed. And do any of you guys know what happens when you take a gas or a liquid and you compress it? When you take a gas and you compress it, what happens? You guys know? It gets hotter. It does get hotter. It gets hotter. Have any of you guys ever had like a can of air, like a can of compressed air? If you've ever had a can of compressed air, like that you use to like clean like computer keyboards or electronics or something, if you've ever had one of those and you spray it and let the air come out, what does that air feel like? Have you ever felt that? It feels super cold, okay? It feels super cold because when you let the air out of that can, it's spreading out. When you let gas spread out, it cools down. When you compress air, it heats up. So essentially what's happening is that the compressed air in front of the meteoroid is getting so hot that that air starts to glow, and it heats up the meteoroid enough that it actually starts to partially melt the outer surface of the meteoroid. And so that makes the outer surface of these meteoroids really smooth and weird looking, right? So here's my question. Every planet can have meteoroids. Every planet can have things falling towards them or falling onto them. One planet can't have meteors. One planet can't have meteors. Does anybody know which one planet can't have a meteor? Think about it. In order to create that streak of light, the meteoroid has to be able to compress atmosphere. You're right. Mercury can't have meteoroids. Why can't Mercury have... Mercury can have meteoroids, but Mercury cannot have meteors. Why can't Mercury have a meteor? What is Mercury missing that makes it so it can't make these streaks of light? Yes, no atmosphere, right? There's no atmosphere. So if you were living on Mercury, which I would not recommend, but if you were, when those meteoroids fall, you wouldn't be able to see the streaks of light. They would just be falling rocks, right? Okay, last word that I want to add to this set. When the meteoroid hits the ground and makes a crater, if it's not completely vaporized in this process, and some of it is left over on the ground, Does anybody know what it's called at that point? Do you guys know what it's called when it hits the ground? There's one more word that looks a lot like these words. Go ahead and start writing it down because I think you guys are going to get it. That's okay. It's called a meteorite. There you go. You guys got it. You got it. Good job. Meteorite. So, physically, a meteoroid is a chunk of material while it is falling. And then when that thing hits the ground, it's called a meteorite from then on. Okay? So a meteoroid becomes a meteorite when it hits the ground. Other than that, there's not really a physical difference between them. So make sure you know the difference between all of these things. Okay? And very last thing I want to say about it. How often is the Earth hit by meteoroids? How often do these things fall from space? Is it a lot? A little bit? Is it a lot or a little bit? Let's just go with that. Do we get hit a lot or a little bit? We actually get hit a lot. A lot. A lot. Like a ridiculous amount. Okay? So, in the time it took me to ask that question, while we were waiting for you guys to answer it, Earth was probably hit by thousands and thousands and thousands of meteoroids. These happen all the time. Like, in the time it takes me to say this sentence, we got hit by several hundred more, probably thousands more, right? Why don't we notice it? Well, number one, what happens to a lot of them up in the sky? What happens to a lot of them before they ever hit the ground? What happens to a lot of them before they ever get all the way down? They burn up. The heat caused by the the heat caused by the compressed air, I almost made that mistake, is actually sometimes enough to completely break the meteoroid apart, sometimes explosively. And also, most of the surface of our planet is not covered in people. Most of these are going to fall in the ocean, and the desert, and the jungle, and the mountains. Very few of them, because people tend to live in cities and towns, those are tiny little targets. Most of the time, it's not hitting us. But if you wanted to find some meteorites, a really good place to go is just a place where people aren't there. Antarctica's full of them. Every desert's full of them. If you go in it far enough out, you're going to find some meteorites if you know what you're looking for.